All right, let's dive into one of the coolest, most elegant features in the Go programming language, its unique take on loops. If you've ever felt that juggling for, while, and do while loops in other languages was just a little bit messy, you are going to absolutely love Go's approach. So let's get into how Go pulls off this incredible simplicity.
It all really starts with this one simple question. How is it possible for one single keyword to do the job of three? And this isn't just some random syntax choice. It's a real window into Go's entire design philosophy. Keep it simple, keep it clear, but make it powerful.
And here's the answer. The designers of Go made this really bold choice to bring all looping under one roof, using a single, super flexible for keyword. That's right, no while, no do while, just for. This one decision cleans up the language so much and gets rid of any confusion. It just gives you one tool that can handle any loop you throw at it.
So, how on earth does this one keyword do all that work? Well, let's break it down by looking at its three fundamental forms. I like to think of them as the three faces of for. First up, you've got the classic C-style loop that we all know if it's three parts: the initializer, the condition, and the post statement. This is your go-to for any counter-based loops. But what if you just need a condition? Simple. You just drop the first and last parts, and just like that, you've got a while loop. And for those times when you need a loop to just run forever until you tell it to stop, just use for with nothing else. It's simple, it's logical, and honestly, it's just so effective.
And here's something else that's really cool. Go really pushes you to write clean code by using short variable declarations. See how we're declaring and initializing the index variable I right there inside the loop? This is great because it keeps the variable scope tucked away neatly right where it belongs. It's a small thing, but it makes a huge difference for writing code that's easy to maintain.
Okay, so getting those three forms of for down is essential. But if you really want to write Go like a seasoned pro, you've got to unlock its other secret weapon, the range keyword. This right here is where Go's approach to iteration really starts to shine.
I mean, just look at the difference. It's immediately obvious. On the left, you've got the old school manual way of looping over a slice. You got to get the length, you got to manage the index. It works, sure, but it's just extra code. But then look at the right. The range keyword is just so much cleaner, so much easier to read. It basically just says what you mean. Hey, I want to go over everything in this collection.
And the real power of range is just how versatile it is. It's not just for slices. It's your one-stop shop for iterating over arrays, strings, maps, and even for pulling values out of channels. It's smart enough to handle the details of iteration for each of those different data types, so you don't have to worry about it. But range is more than just a simple iterator. It's also incredibly flexible, and it gives you really precise control over what data you get back. Let's take a look at how that actually works.
Okay, so the most common thing you'll do, especially with maps, is grab both the key and the value with each pass. Range just hands them to you as a pair, and you can assign them to two variables right there in the loop. It just feels so natural. But what if you don't care about the value? Maybe you just need to check if some keys exist in a map. Easy. Just give it one variable, and Go knows to automatically give you the key, or if you're ranging over a slice or an array, it'll give you the index. Now let's flip that around. What if you only want the value? Say you're just trying to add up all the numbers in an array. Well, you can't just drop the first variable because the syntax needs something there for the key. And this is where we meet one of Go's coolest little features, the blank identifier. That's the underscore. It's our way of telling the compiler, yeah, I know a value goes here, but I'm just going to ignore it. So what exactly is this blank identifier? Well, you can think of it as a fundamental concept in Go. It's like a write-only variable, a little black hole for any values you don't need. It lets you satisfy Go's syntax rules without having to create a bunch of variables that you're never going to use. It's a simple little tool that helps you write really clean, explicit code. So far, range has been clean, convenient, powerful. But what it does with strings, well, that's nothing short of magical. This is where range shows off its hidden superpower, its deep, built-in understanding of Unicode. Okay, before we see the magic trick, we gotta learn one key term, rune. In Go, a rune isn't just a character. It's actually an integer type that represents a single Unicode code point. And that distinction is so important because a single visual character, like an emoji or a Japanese kanji, can actually be made up of multiple bytes of data. All right, look closely at this line of code.
We're using range to loop over a string that has a couple of Japanese characters and one Go character. But I've sneakily tucked something in there, /x80. That's an illegal, totally invalid byte in a UTF-8 sequence. So what do you think happens when range stumbles upon that?
The result is pretty amazing. See, range decodes the string rune by rune, not byte by byte. It correctly identifies that first character at position 0. It knows it's 3 bytes long, so it finds the next one starting at byte position 3. And here's the crucial part. When it gets to that illegal byte at position 6, it doesn't crash, it doesn't panic, it just substitutes in that special Unicode replacement character and keeps right on going. This is incredibly robust, safe string handling, and it's built right into the language. We're almost at the end, but I've got one final, really slick looping trick to show you. Think of this as a pro tip for those times when you need to juggle multiple variables inside your loop. So why do we even need a trick for this? Well, if you're coming from a language like C, you might be used to using the comma operator to update multiple variables in your loop. But Go doesn't have that. On top of that, the increment and decrement operators, plus plus and minus minus, are statements in Go, not expressions, which means you can't chain them together on one line like I plus plus, J minus minus. Go's solution is just so much cleaner. It's called parallel assignment. Take a look at this code for reversing an array. In that first part, the init statement, we're initializing both I and J at the same time. Then, in the last part, the post statement, we update them both in a single, clean operation. This is the idiomatic Go way of doing things, and it's both powerful and really easy to understand.
So, as we've seen, for and range aren't just bits of syntax. They're really a reflection of Go's entire design philosophy: to be powerful, to be clear, and to focus on making a developer's life easier. And that kind of leaves us with one final thought. If one keyword can be this powerful and this elegant, what other brilliant simplicities are just waiting to be discovered in Go? Now that's something worth exploring.